Now we are in our third lesson here on multiplying and dividing real numbers. Again, an important distinction, but all the numbers for this class will be real. So we're going to be multiplying and dividing these real numbers today. Rules for multiplying and dividing, much less complicated than adding or subtracting, I guess. For multiplying and dividing, if they have the same sign, both positive and negative, the answer is positive. If they have different signs, one positive, one negative, the answer is always negative. So much easier to remember. However, confusing them with the addition rules is the hardest thing. So be very careful that you're not mixing and matching your rules. For multiplication and division, same sign, positive. For multiplication and division, different signs, negative. And be very careful to not mix that up with your addition rules. We're going to look at some examples here. So we're looking at fractions. Fractions are real numbers. They're really real. So we're multiplying fractions. Remember that when you're multiplying, you do not need common denominators. You can, but it's kind of a waste of your time. You don't need them. We're just looking at splitting things up a little bit more, and so we just need to have any denominator. They don't need to be common. And so we're going to multiply the numerators together. 2 times 6 is going to give us 12, and we're going to multiply the denominators together. 5 times 7, 35. We need to make sure that we look. Both of those numbers are positive, which means the answer will be positive. Can we reduce it? 12 and 35, we can't divide them both by 2, can't divide them both by 3, 5, 10, 7, 8. So that is reduced. We have our simplified answer, 12/35. Next one we've got 7/8 times 9/23. So again, I'm going to multiply. I'm going to multiply the numerators together. 7 times 9 is going to give me 63. 8 times 23 is going to give me 184. Double check my mental math here. Yes, 184. And so when we're looking at that's a little harder to figure out if we can divide them both by the same thing. But for reducing, we are going to end up, in this case, being simplified. We can't divide both 184 and 63 by the same number. And we look again. Both of the numbers are positive, which means our solution is going to be positive. Same sign, positive. And the last one here on this page, we've got 4/7 times 5/12. I'm going to multiply straight across again. I'm going to multiply the numerator times the numerator, denominator times the denominator. Do not cross multiply. Cross multiplying is with proportions. We'll get to that later in chapter 2. And so we're just going to multiply the numerators together. We're going to get 20. We're going to multiply the denominators together, and we're going to get 84. We can reduce this. We can reduce this. They are both positive numbers, 4/7 and 5/12, which means the answer is still positive. We can reduce this. We can divide them both by 2. We can divide them both by 4. And I think that's about it. Since I can divide them both by 2, and I can divide both these numbers by 4, I'm going to choose the larger one. I'm going to choose the greatest common divisor. I'm going to divide them both by 4. And I'm going to get 20 divided by 4 is 5. And 84 divided by 4 is 21. And we got 5/21 as our final answer. There is another way to do this. There is another way to multiply these numbers together and reduce. You'll notice that I multiplied first, then I reduced. You can flip the order. Another way to do it, I'm going to rewrite the numbers down here. So we have 4/7 times 5/12. You can do what's called cross-simplifying. Cross-simplifying is saying, well, if I cover up the 7 and the 5, which you can't see my hands doing it, but cover up the 7 and the 5, then we're looking only at the 4 and the 12. If you can divide both 4 and 12 by the same thing, which we can in this case, we can divide 4 by 4. 4 divided by 4 is 1. And we can divide 12 by 4. 12 divided by 4 is 3. So we've done some cross-simplifying. We do the same thing with the 5 and the 7. If I look at just the 5 and the 7, can I divide both 5 and 7 by the same thing? No. Those are both prime numbers. We can't divide it any further. And so I can't do any cross-simplifying with those. Now if I multiply, 1 times 5 is 5. 7 times 3, 21. I have my same simplified answer of 5/21. Neither one is faster, neither one is easier. It depends on what you're most comfortable with. You still have to multiply. You still have to reduce. It just depends on what order you want to do it. Both ways are correct as long as you show me some work. So what I've shown here is the exact amount of work that I need to see to get full points. So I need to see the work that you're doing, either multiplying and then reducing, or reducing then multiplying. Okay, multiplication with decimals. Hey, there's Shaggy. Shaggy is scared. We're going to get rid of him now, though, because we don't need a scaredy cat working with these decimals. And so we've got our decimal problems here. Try this on your own. Be careful of those negatives, and we'll come back to it in a second. We're going to assume that you paused it and that you tried these on your own. Remember that when you're multiplying with decimals, we can just line it up. Doesn't matter which way. We're going to line it up as if the decimals weren't there. So instead of putting 0.78 times 3.5, I'm going to forget about those decimals for a minute. I'm going to erase it, and I'm going to erase it. I'm just going to multiply. I'm going to multiply just like I would if they were normal numbers, and I'm going to do my long multiplication. Now, if you do lattice, that's fine. This method should still work, but I'm not as comfortable with lattice, so I'm going to do it this way. So if I multiply, 5 times 8 is going to give me 40, carry the 4. 5 times 7 is going to give me 35. I add those 4 in there, I've got 39. 5 times 0 is 0, plus 3 more, 3. Now I do the tens. So I did the ones times 0.78, and now I'm going to multiply the tens. 3 times 0.78. So I'm going to do 3 times 8, and that's going to give me 24. And I carry the 2 up here. I multiply 3 times 7, and I'm going to get 21. Add the 2 on, I get 23. And you'll notice I started that 4 underneath the 9. What really is happening there is I'm starting that 4 underneath the tens, underneath the 3, because that's what I'm multiplying with. I'm not multiplying with the 5 anymore. I'm not multiplying with the 1s. I'm multiplying with the tens place. And so that number is going to start underneath the tens place. Now I multiply 3 times 0 is 0, plus 2 more is going to give me 2. Add them together. 0 plus nothing is 0. 9 plus 4, carry the 1. And I'm going to get 2,730. Of course, I need to go back. I need to look at those decimals. There's no way that 0.78, 78 hundredths, times 3 and 5 tenths is 2,000 something. Not going to happen. I'm going to put those decimal points back in. Now I'm simply going to count how many numbers are on the right side of the decimal points. In fact, I can draw a line here. I can say, well, here's the decimal points. How many numbers are on the right side? 3, 7, 8, and 5. 3 numbers. So my answer, there needs to be 3 numbers on the right side of the decimal point. If I put the decimal point here, there's only 2 numbers on the right side of the decimal point. That is going to be incorrect. So I need to put that decimal in between the 2 and the 7. Now there are 3 numbers on the right side of the decimal point. 0.78 times 3.5 is 2.73. The 0 you can leave on if you want. You don't need it, though. And I have to be very careful. I've got the right number. However, I'm multiplying, and these 2 numbers have different signs, positive and negative. If I go back to my rules, positive and negative, different signs, the answer should be negative. So it's negative 2 and 73 hundredths. We do the second one here. We've got 2.05 times 5.7. I'm going to go a little bit faster here. Get out of here, Shaggy. We don't want the scared Shaggy. Okay. Going back then, so I've got a new problem here. I'm going to do 2.05 times 5.7. Again, I'm going to forget about those decimals for a little bit. I'm going to leave them there just because I don't want to erase them. But I'm going to multiply as if they're not there. 7 times 5, 35. And again, I'm going to go through this a little bit faster, but you should, it's the same process over again. I'm going to carry the 2, 5 times 2, 5 times 2 is 10. Add those together, and I'm going to get, if you want to put a 0 here, that's just fine. If you want to fill in that gap, if that makes you feel better, go for it. You can leave it blank like I did here because it's nothing. 0 is nothing. And you can certainly add it in if you want. Up to you. And I should get then my answer. Again, there's no way it's 11,685, so I have to count. How many numbers are on the right side of the decimal? 3. So my answer, 3. Now, I know that 2 times 5 is 10. So 2.05 times 5.7 11.685, sure, that seems reasonable. We should be able to say that yes, that's a reasonable answer, or no, there's no way that's possible. 11.685 seems like a reasonable answer. Now I look, negative 2.05, negative 5.7. Same sign, positive. Not same sign, keep the sign the same. That's adding. So if we were adding these together, it'd be negative. But since we're multiplying, we have a different set of rules. Multiplying, they have the same sign as positive. Last one then, 4 times 0, anything times 0 is just 0. There is no positive or negative 0, it's just 0. And so we can leave that there. Okay, and if we keep going then, we're going to look at division, dividing with fractions. Division with fractions is one extra step on top of multiplication. To divide with fractions, we're going to take the reciprocal of the second number. So we're going to take that second number, 6/7 in this case, we're going to take the reciprocal. You're not going to need to memorize that name, however, you do need to know how to do it. And so the reciprocal is when you flip it over and you make it 6/7. This does not make it positive or negative. It doesn't change that. It just flips the sign. Or excuse me, it flips the number over. It's called the reciprocal. First number stays the same. We change it to multiplication, and we take the reciprocal of the last number, but we do not make it positive or negative. We just leave it alone. Now I can multiply. Now I'm going to do some cross multiplication, or cross reducing, excuse me. I see that 5 and 7, can't do any cross reducing there. They're both prime. However, 2 and 6, I can divide both 2 and 6 by the same number. I can divide 2 by 2 and get 1, divide 6 by 2 and get 3. So now when I multiply to get my final answer, 1 times 7 is 7, 5 times 3 is 15. I have a reduced answer. Both of these numbers were positive, which means that if they have the same sign, it's a positive answer in the end. Pause it, try these next two on your own. Assume you've tried them, so we're going to go through these. Again, before I do any cross simplifying, I have to flip them over. And so I'm going to take that second fraction, and I'm going to take the reciprocal. If you want to know why this works, why we can do this and actually have it make a correct answer, I will explain it in class if you ask. I'm not going to do it here though. But there is a very good reason of why that works. Now if I look, I don't think I can do any cross simplifying with this one. 7 and 9, nope, 7 is prime. I can't divide 9 by 7. 23 and 8, not quite. If it was a 24, I could. So I multiply. 7 times 23, 161, I believe. Yep, 161. 8 times 9 is going to give me 72. Now, I can't reduce this. However, it's not simplified. We've got an improper fraction. So I have to figure out how many times is 72 going to 161. Okay, so if I'm looking, well, I'm just going to do a little scratch work over here. 161 divided by 72, because remember, a fraction is just division. It's the numerator divided by the denominator. That's where we get that divide sign. And so I'm going to divide. I'm going to divide 61 divided by 72, or 161 divided by 72, excuse me. And I believe that can go in there twice. Let's give it a shot. 2 times 2 is 4. 2 times 7 is 14. And if I subtract, I should get what? 17, I believe. And so when I subtract 17, that's less than 72, which means I have a remainder of 17. However, we're not going to write remainders. We're a little bit more advanced than that now. We're no longer going to do remainders. That remainder is 17/72 left over. So we've got 2 and 17/72. That is our final answer then. I'm going to double check. I can't reduce that any further. 17 is prime. And I looked, both the original numbers, 7/8 and 9/23, were positive. And so if they have the same sign, my answer is also going to be positive. Last one, again, I'm going to take the reciprocal of the second number. I've got 12/5, and I'm going to make this a multiplication, and I leave the first number alone, 4/7. I can't do any cross simplifying, so I'm just going to multiply straight across. 4 times 12 is going to give me 48, and 7 times 5 is going to give me 35. This is improper. I'm going to have to divide 48 divided by 35. 35 only goes into 48 once. They're pretty close together. And so when I subtract, I'm going to get 13 left over. Again, my remainder of 13 I can write as a fraction, 1 and 13/35. 13 is prime, which means we can't reduce that any further. 1 and 13/35. Again, both of my original numbers were positive numbers, and so if they have the same sign, the answer is positive. Last little bit here, we're going to do some division with decimals. So I'm going to have you take a minute. I'm going to have you try these on your own, and then we'll try them together. Okay, I'm going to assume that you paused it and you tried these. When you're setting up for division and decimals, you are going to set it up very similar to if you had normal numbers, or not normal numbers, but whole numbers. And so we've got 0.78 divided by 3.6. Now it is negative, but I'm going to come back to that. I'm going to look at it again, but it is negative. So we've got our setup there. Remember, the first number goes inside the box or the house or whatever you want to call it, but the first number always goes inside of that box or house. And now before we can divide with decimals, there's one step you have to take. We need to get a whole number on the outside of that box or that house. And so I'm going to move the decimal one time to the right, and that will give me a whole number 36. Now I do not need to have a whole number on the inside. It's okay to have a decimal on the inside. That works for us. But I do have to do the same thing. I have to move her one time, only once. So I'm not going to get a whole number. I'm not going to get 78. 7.8. And now I can divide. So I'm going to ask, how many times does 36 go into 7? No, it doesn't. The decimal point comes up. How many times does 36 go into 78? Now we're looking at, is that 3 times? 3 times. 3 times 6 is going to give me 18. 3 times, oh, no, I was way off. 2 times. So I'm going to, so I tried. I gave it a guess. It didn't work. So I'm going to try again. So 3 was way too big, and so I'm going to go with 2. 2 times 6 is 12. I'll carry the 1. 2 times 3 is 6, plus 1 more is 7. And that just barely fits underneath. And so when we subtract, I've got 6 remaining. I can add a 0. You can always add more zeros. The zeros are there. There's 0 hundredths. There's 0 thousandths. There's 0 ten thousandths. There's 0 hundredths. There's 0 billionths. But we don't put them on there. We just remember that there aren't any. But we can always put them back in. And so we've got that 0. Now I'm going to pull that down. How does 36 go into 60? Now 36 goes into 60 only once, because I know that 2 times is 72. That's too big. So I'm going to subtract, and I'm going to get 24. Add another 0. Pull it down. 36 into 240. I'm going to guess 6 times. But again, I'm not positive, so I'm going to guess. 6 times 6 is going to give you 36. 6 times 3 is going to give you 18. And we got 21 there. And at this point, I'm going to go ahead and have you stop. I maybe should check this a little bit better. But this one doesn't quite work the way we want it to. It's going to go a little bit long. On your assignment, on your tests, you will be stopping by at least the third. You may get to the third number, however, the thousandth place. However, I'm not going to make you go past that in your handwork. But if we do this, then we get, 24 again? Oh, here we go. So we got 24. And so we're going to have, okay, if I add that 0, there's that 240. Oh, so we're going to get the same thing again. We're going to get 6. And of course, if I do that, and I know some of you already know what to do, but if I do that again, I'm going to keep getting the same thing, and it's just going to repeat. And remember that when we have a repeating decimal, you can draw a line and say, well, it's 0.216 repeating, and that 6 is going to keep repeating. So that one did work out. That one did work out to be a repeating decimal point that we can handle. That was a long one. We do need to go back. We've got our answer, 0.216 repeating. However, we have a positive and a negative. Different signs, negative result. Next one, negative 2.05 divided by negative 5. So again, give myself a little bit of room here. We're going to set it up. The first number goes inside. Second number goes outside. I'm actually going to get rid of that negative for now, just so I don't get confused. And we've got a division problem. I already have a whole number. Don't have to worry about the decimals then. 5 does not go into 2. Can pull that decimal point up. 5 goes into 20 4 times. 4 times 5 is 20. Pull down that 5. 5 goes into 5 one whole time, and that works exactly the way we want it to with no remainder, 0.41. Now I've got a negative 2.05 and a negative 5. They have the same sign, it's going to be positive. Even if they're both negatives, it's still a positive result. And the last one, 4 divided by 0. Now this is where it gets a little bit tricky. 4 times 0, back here, 4 times 0, there's Shaggy, scared again. 4 times 0 is 0. Anything times 0 is 0. 4 groups of 0 is still nothing. If I have 4 divided by 0, 4 divided by 0 means I have $4, and I'm going to put those $4 in 0 piles. I'm going to divide it into 0 piles. You can't do that. You have to have at least one pile of those dollars. They don't disappear. You can say, well, I put it underneath my bed, but that's different. You can put them in one pile, but you cannot put $4 in 0 piles. You can't have 0 bank accounts with $4 in it. You have to have at least one place for those $4. And so 4 divided by 0, whenever you're dividing by 0, either like this or in this way here, it is undefined. And that's your final answer for that. 4 divided by 0 is undefined. We don't have a definition for that. That doesn't work. It doesn't even work with our imaginary numbers. It doesn't work with any numbers. You can't divide by 0. It's undefined. You can, however, take 0 divided by 4. If I have $0, I can give $0 to 4 different people. They each get nothing. They each get 0. So you can take 4, or you can take nothing and divide it into as many groups as you want, as many piles as you want. Every pile has nothing in it. That's fairly easy to do. I can take nothing and divide it into 1 billion piles. Every pile is 0. I can't take 4 of something and make 0 piles of it. That's impossible in our math. That's undefined. Okay, so that's it. Good luck on the pre-quiz and on the assessment, and we'll talk to you in class.